I'm going to focus on this bit now and use partial fractions, aren't we, to separate it. So what's the first thing to do with this fraction? Yeah, we've got to factorise the bottom. This bottom term here, factorise it. Turn it into two brackets, remember, x, x. What are these two missing numbers? Okay, factorise it. We can use the quadratic formula if we're stuck, but often, and certainly if you were given something like this in the exam, you'd be able to factorise it by inspection. In other words, think of two numbers that add together to give this one and multiply together to give that one. So two numbers that multiply to give -3, that's the one to focus on first, because 3 and 1 are the only two whole numbers that are going to give 3 when you multiply them together. So what combination of 3 and 1 will add up to give -2? 3 and 1 is 1. Say again? 3 and 1 is 1. To give -2.
Oh, -2.
Yeah, so it'd be -3 plus 1, won't it? Okay? So those are our two factors. So in other words, we can take this, focusing on the second fraction, x minus 11 over x squared minus 2x minus 3 can become x minus 11 over x minus 3 x plus 1. And if I was doing this, I would check. I'd multiply out this x times x gives x squared, so that's that. X times 1 is x. Minus 3 times x is minus, so x minus 3x is minus 2x, which is that. And then finally, minus 3 times 1 gives us our -3. So if I multiply out this, it's the same thing. I've just rewritten it. It's an equivalence. This is the same as that, so I could actually write this. Equivalent to. I've just rewritten it. And we do that because I can then say x minus 11 over x minus 3, x plus 1, now it's been factorised, can be written as some number over x minus 3 plus some number over x plus 1. And we're into partial fractions, aren't we? You're bound to get a question like this in the exam on partial fractions. It can be a bit long-winded, I admit, but the beauty of it is it's a technique that you can learn and revise, and you just go out through that technique. There's nothing magical about it, you just got to learn how to do it. Okay? And so the steps we've been through a few times. What do we do now? The steps are sort of the same every time, so what's the first one?
Cross multiply.
First step is we're going to actually recombine this side so that that denominator is the same as that denominator, and then we can equate numerators, if you remember. So the first step is to rewrite this right-hand side as one fraction over x minus 3x plus 1. And yes, cross multiply is what we're doing. If we look at this first one, I want the denominator of this first one to be this. So what's missing is the x plus 1 term. So I have to multiply top and bottom of this fraction by x plus 1. So in other words, I multiply a by x plus 1. And similarly, if I want this fraction to look like that, I've got to multiply by x minus 3. So I multiply b by the denominator underneath the a term, and a by the denominator underneath the b term. In other words, cross multiply. So this equals a times x plus 1 plus b times x minus 3. Becomes a little bit more involved if I've got 3 or more terms underneath, but the principle's the same. So now x minus 11, the original one, over x minus 3, x plus 1, is equivalent to this. And we've got to find, we've got to find A and B. What do we do now? A statement we're going to write down. We're going to be correct about it mathematically. We equate numerators. If we look at these two fractions, the denominator is the same on both sides, so if they're equivalent, the tops must also be the same. We equate numerators. And if you're going to be correct about it, you should state that. I'm not going to be that pedantic, but in theory that's what you should do. State what you're going to do. So in other words, x minus 11 equals this top, a x plus 1 plus b x minus 3. X minus 11 equals a x plus 1 plus b x minus 3. Okay, so now do you remember what we do to find a and b?
Do that a equals
Not a.
x.
Good. So what could I let x equal to help?
Oh yeah.
I've got two unknowns, a and b, so I could do with getting rid of one of them so I could find the other.
X equal minus 1.
Yeah. If I let x equal minus 1, then that bracket disappears and a disappears and we can find b. And then to find a, what would I do then?
X equal
Yeah. Let x equal 3, and so then this bracket disappears, so therefore the b disappears and we can find a. So, find a and b. So letting x equal minus 1, because x is minus 1, minus 11 on the left hand side, in other words, I'll replace x throughout here with minus 1. So minus 1 minus 11, which is this bit, equals minus 1 plus 1 is 0, so that means this term has gone, right? And then we're just left with b times minus 1 minus 3. Minus 1 minus 3. Again, because x equals minus 1. Right, Daniel? So, minus 1 minus 11 is minus 12. Minus 1 minus 3 is minus 4. So we've got that minus 12 equals minus 4b, and then dividing by minus 4, b equals minus 12 over minus 4, which is plus 3. And then we do a similar thing to find a. So now let x equal 3, because by letting x equal 3, that means this term disappears, because 3 minus 3 is 0, and we can find a. So carry on and see if you can find out what a is. So hopefully you got this, letting x equal 3, we've got 3 minus 11 equals a, 3 plus 1, so a equals, x equals 3, and that gives us a equal to minus 2. Okay. So now we can rewrite our original integral, going back to the top here, this original integral. Remember we used polynomial division to get to this bit, to get the 1, and now we've rewritten this as two partial fractions, and we now know the values of a and b, so we can rewrite the original integral and then hopefully do it. So we've got finally the integral between 4 and 6, 1 plus, well, the a is negative and b is positive, so let's start off with the b term. So b is the term over x plus 1, so it'll be plus e was 3 minus 2 over the x minus 3 term. And so we've now got to do this integral. And that just means we've got to integrate each part in turn separately using our table of standard integrals, and then put in the values x equals 6 and x equals 4 to work out the definite integral. So I'll stop this video here and then I'll do that solution in the next video.